Our concept getters, how are you? I hope you are good and I hope the anxiety is not that hectic and intense and I hope you are handling exams well. But anyway, I'm not here to give a motivational speech. I'm here to simplify your math, okay? When you're looking at your screen, you see that I'm going to teach you how to present the rules of differentiation and also what it requires of you. The minute they say differentiate a particular problem and they gave you in different formats, I'm going to show you how the formats work and I'm also going to show you how to just differentiate using the rule. Simple, right? So let's see how that works out. They give us a question here. Let's see it. Okay, they give us a question here. They said f of x equals to x to the exponent 6 minus 27 x cubed all over x squared minus 3x. On the side there, you can see I have written d over dx, yada, 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 inside the brackets, which is the same question, or d to the subscript of x, yada, yada, the same question, or y equals to. No matter how they give you the question, you do the same thing, but the format will just differ here and there, okay? All the formats will require you to simplify before you differentiate. They change where you're gonna introduce either the f prime x or whether you're gonna introduce the equal sign for these ones, or where you're gonna introduce the dy over dx equal to for this one, and sometimes for this one can also lead you to saying y prime equals to. You see, these and this are for when you differentiate, on the step of differentiating. But then before you differentiate, when you simplify, you rewrite the format the way it was given in the question. So let's do this one. I don't want to do a lot of talking. I want to do a lot of doing and explaining or simplifying. Come on, Mr. Say. So we have f of x here, okay? F of x is equals to x to the exponent 6 minus 27 x cubed over x squared minus 3x. With this specific question, they want you to simplify first, okay? So you're just going to rewrite the f of x. You're going to say f of x equal to, then when I look at my numerator, I see this is difference of two cubes. For those who don't know how to factorize difference and sums of two cubes, you can check one of the videos. I've already uploaded it like a few months ago, I think. I'll just drop the link on the description, okay? Just go to the description and you'll see the link. So you have to watch that video first for you to really understand this and to really be able to apply it if a question differs, okay? But right now I'm just going to apply it. I'm not going to teach difference of two cubes. Come on, you're in grade 12. So we're going to say what? We're going to say x to the exponent 2 all cubed, right? Then minus, then I'm going to have 3x all cubed all over x squared minus 3x. Then I'll say f of x again. F of x equal to what? Now this is difference of two cubes. So we all know that I'm going to have x squared minus 3x into, then this one squared is going to give me x to the exponent 4. Then if here it's minus, here it's going to be a plus. And then I will multiply this and this. Then I will have what? 3x cubed. And then the last term is always a plus. And I'll square this one, which is going to be 9x squared. Then I close. Then all over x squared minus 3x. I can bracket it. And then the next step is to say, oh, this cancels this, which means now I simplified. Then it's going to give me what? F of x is equal to x to the exponent 4 plus 3x cubed plus 9x squared. Remember, look at this. Now I'm going to write it in green. Always a derivative of a function, right? A derivative of a function will always be what? Will always be this one. It's going to go here and multiply the coefficient. Then the same this one will minus 1. Always the exponent will have 1 subtracted from it, and then that exponent, the original exponent, will multiply the coefficient of the variable the exponent carries all the time. So every time when you have ax to the exponent n, the derivative will be what? N times a, meaning this will multiply this, right? So it will be n times a, then x variable, you write it, then n minus 1, right? I will subtract 1 from the n, so it's going to be n minus 1. Always. That's why we always need it to be in this format. Okay, every term. So here I will just say my answer will be what? It will be 4x to the exponent 3. Then plus, again, my answer will be here 9x to the exponent 2, because 3 times 3 is 9, 3 minus 1 is 2. Then plus, 2 times 9 is 18. Then x, 2 minus 1, come on, x 2 minus 1 is just going to be x to the exponent 1, which is the same as x, because any base carrying an exponent of 1 is that base. So the base won't have an exponent. It will have, it is just 1, but I'm not going to write it. Then basically I'm done with this question. That's going to be the last answer. But remember, this video is just not about differentiating. This video is about how do I present this in the exam if it's going to be in this form. So let's look at it, right? I'm going to say, now imagine if it was presented in this form. I'm going to erase this. Then I'm going to say, imagine if it was like d over dx into. Makes sense? Then when you simplify, when I go to this step, I'm just going to rewrite this. I'm going to say d over dx into. Then I do this. Even on this step, because I was simplifying, I'm just going to write d over dx into. Then you simplify. Do that make sense? Then you also want to write d over dx into. Then because on this step I was differentiating, this last step here, I'm just going to write equal to. You don't write d over dx on the step where you differentiated. That's how the format works for this one. Okay, the first one on your right. The question is now, Mr. Say, what about this one here? Same thing, guys, same thing. Same thing. All you have to do is, I'm going to erase. Then I'm going to say, even with this one, you're just going to write d and the subscript of x. D and the subscript of x. Okay, same thing, guys. Even here, d and the subscript of x. D and the subscript of x. But on the step where you differentiated, you just write equal to. That's how it works. You see the same thing? And then what if they gave me a question in this format, Mr. Say? What if the question was like, Mr. Say, differentiate this. They said y equals to. Then you're going to do the same thing again. You're just going to say, let's erase. You're just going to say y equals to. Y equals to. Y equals to. As you simplify, you just simply rewrite the y equals to. But on the last step, you see the step where you differentiated. Then you're just going to say dy over dx equal to. So when you differentiate y equal to, the derivative will be dy over dx equal to. Simple, right? And other times, they will tell you to present your answer in this form, y prime equal to. Right? So instead of writing dy over dx equal to, what you're going to write? You're just going to write y prime equal to on the step where you differentiated. So it does not matter how the question comes, the format they ask the question. Just know you're going to rewrite the format the whole time you are simplifying until you have ax to the exponent n, right, in all the terms. Then the last step where you differentiate, the step where you differentiated, that's where now you can actually present your answer. For this one, remember, the last step will just take equal to the answer. For this one as well, the answer will just take equals to as the answer. But for y equals to, you're going to say dy over dx, right? Or you're going to say y prime. And then for f of x equals to, if the question came as f of x equals to, the answer would just be f prime x equal to derivative. Those are the formats of differentiation. Simple, guys. Simple. Let's go past, right? Let's go past. Oh, wait. Remember, guys, remember. You have to do what? You have to subscribe and Sure, come on, come on, come on. Thank you.